Good evening, America. I am so dang cold today that it would be an understatement to say that it's cold. It's like 0 degrees Fahrenheit right now. I mean, this is going to be in Celsius. Fahrenheit, oh, okay. It's 10. I don't know what I'm talking about. Um, sure feels like 0 degrees Fahrenheit because it's minus 12. Um, yeah. Deep chill forecast is not wrong. Like tomorrow, the temperature just isn't going to change at all. Like it's going to be the high and the low is pretty much the same temperature, which is kind of crazy. So yeah, it's gonna be a great day to celebrate Christmas here in New York tomorrow. I guess it's true for most of the states right now. Um, Still not getting any snow, that's for sure. But we got more Advent of Code to do. So that's great. I'm preparing here for the second last day of puzzles. Now, of course, we haven't nearly finished all of them. And I think there's like one full day left that we didn't even touch, and then two second parts that are missing. I think the day we didn't touch at all isn't going to be too complicated. I just didn't want to deal with that for some reason yesterday. But maybe it was a pretty long day. You can't do them every single day, right? So let's activate the environment here. Get ready to start creating folder 24. Um, we could be making a couple of changes to our template here. I feel like some typing stuff, although we did remove Pyland, so I think this is not going to be an issue. I think what I would do want to do is to add move 3D here, which is gonna be adding a third dimension to all of my movement vectors, um, which is gonna be front and back. Yeah, this would have come in handy once. Then we also got maybe int, which we didn't put into the template. What else? I think I think that's pretty much all the convenient stuff that I could think of right now. I mean the double linked list, which is kind of niche, and we also do import a double linked list already, but I just don't know any of the API for it, and I don't know if it supports cyclic references. So writing our own was actually the right approach that one time. Um, yeah, kind of contemplating if I do want to do after 24, if I want to continue debugging the cube, or if I want to just call it a day, or maybe start working on the Game of Life stuff. Might just call it a day. We did work on the cube for almost an hour today, and that wasn't enough. So that's going to tell you how that's going to go. Just double and triple checking if my screen sharing is working today because it's been choosing to not work. There's one time too many. Where did I put my phone? It's gone. No, it's not. Not that it matters. Um, but yeah, about 40 seconds to go here. And I'm excited. I think it's gonna get a lot easier. I have a feeling that the last years, day 25 was usually pretty easy. And I think day 24 was pretty easy as well. So I'm holding out hope for that. And we got about 10 seconds here before the penultimate day is gonna get started. So I'm curious what the puzzle is gonna hold today. Blizzard Basin. Uh, it's gonna be BFS. Interesting. Okay. Mm-hmm. Right. Wow. Interesting. Okay. Hmm. Interesting. I have a feeling that maybe DFS is gonna be correct here. So we do backtracking. Man, wow. Fascinating. Okay, let's parse this, shall we? So we're gonna do R lmap int np array replace dot with 0, replace wall with 1. No, you won't know what wall is gonna be. And then we want to do 1, 2, 3, 4. For um, up, down, left, right. Let's see if we parse this correctly. We did not. Why did we not parse this correctly? The heck? The heck? Oh, I'm working the template. Oh my goodness. How did this happen? Oof. Print T. Okay, looking good. So next up, we want to find for x, y, and z of np where p equals and x. This should give us all the coordinates x and y of the things facing up. So we got up, down, left, right. I think I got that in the right order. Up, down, left, right. Perfect. So let's add lizards is nothing. Lizards and x, y, and movement 0 as a tuple, of course. So we do the same for 1, 2, 3, and 4. We got 1, 2, 3. Now we have all the blizzards. So now for every time point, we can find out if it's occupied by any blizzard. And in fact, we only have to check the ones which are in the right vicinity. So we have can walk. Oops. And I have that. Yeah, that's fine. So we got no blizzard for X, Y, T. And T0, we got those positions. Okay. For BX, no, for BP and BM in blizzards, BX, BY equals BP. We need to do the, oh no, that's fine. Okay. So what we want to check is if BX not equal to X or BM0 equal to 0. No, what we want is to be in the same, if X is not equal, no, if BX is equal and this is also true for the Y's. So the Y's have to be equal and the movement in the other direction should not be equal. Correct. if y equals by minus 1 plus mb1 times t plus 1 percentage sign m. So we got global blizz n and m equals t shape, n minus equals 2 because we don't care about the walls, and m minus equals 2. Then we return false. Return true. Okay. So now we got to do bx, and we have to figure out the movement of 0. And we do minus 1 plus 1, so we get the modulo figured out. Perfect. Okay. And of course we have. So let's check this for the first test input, where we're going to check the position x equals 0, 1, 2. Let's check 2, 2. Why not? Should be false for t1, otherwise true. Print no blizz for 2, 2, 0, 1, 2. Let's just check this. And of course, we want to run the test input. So we have to put this in here. AOCR, MB is not defined. That's correct because I called it BM. Yeah, man, that seems to be working fine, just fine. 0, 1, 2, 3, 4, 5, 6. So it should be true for 6 again. So let's do this a bunch of times more often. And let's see if the second last is true. Man, that's working amazingly. So I think we do want to do BFS now. So the only thing we have to do for this is to figure out the time. Dude, I mean, can walk with position and cost as the parameters might actually be where it's at here. I don't know, maybe I'm crazy, but print. Okay, so we do have a goal, which is a method, yes. Okay, so we want to run res equals BFS for start is 0, 1, can walk is no blizzard for XYT. The goal is lambda p equals 2. Gotta do these parametrically, don't I? Well, this is always going to be 0, 1. Can tell you that much. And the other one is always going to be n plus 1 and m plus 1, except this is actually going to be m because it's the count -2. Yeah, yeah, I think this is correct. Do we have any other parameters? There is no cost function. It's none. Let's print res. What are we going for? Is tender an answer here? Let's run the more complex example. 18. Let's see if we get the right result. Well, we don't get the right result. Damn it. What's wrong? Is it cost plus 1? I think it's cost plus 1. Nope. Is 12 just running straight through? Oh, we can also wait. Ah, damn. This is not going to make it shorter, though, because we already found a path, which we shouldn't have been able to find. Hmm, very interesting. Very, very interesting. Well, first of all, this is supposed to happen here. Not gonna make a difference. 12 just appears to me to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Eh, it's not just walking straight through, but it's certainly not. Mm, mm. I have a question. It's not going to be plus 1. It's going to be cost because we already added the cost there. Nope, not true. So we try this now, which is going to be moving 1 down. It's going to cost 1. So it's going to give us no blizzard, which is x and y, with the cost value of 1. Now, I think this stuff should not be accounted for. Maybe it should. I mean, Probably not, but who knows? Anyway, is my goal correct? Let's print, I mean, we can just figure it out. The full length, so we would be there, -2. So we're here. Yeah, me, that looks like the right coordinate. Um, no, wait, this can't be true. Okay, this thing is 8 wide, so this is going to be 7, 6. So we're going to move down to 0, 1, 2, 3, 4, 5. Oh, it's 1, 2, 3, 4, 5, 6 tall. So we move to 6. I mean, -1 is 5. 0, 1, 2, 3, 4, 5. So that's true. Okay. I should definitely not spend so much time on this, but something is wrong here, and I want to know what it is. How are we able to reach the goal if this is... Oh, I think I know what it is. I think I definitely know what it is. This is supposed to be an N. No, it's not what it is. Well, was worth a try, wasn't it? God damn it. So there's going to be a lot of wrong values here. So before we assert can walk, because that's not holding true for values outside, we should run this. So let's see. Apparently we're able to move down at 1, 1. That's true. Then we move to 0, 0. Ah, okay. That makes a lot of sense. Um, so if it's greater than n, -1, maybe. No, I think just n and n. None. Interesting. So I think we do have to do backtracking. 18. Not correct. Why is that? Because the answer is none. Okay, fair enough. Um, we're too strict somewhere. We are able to get to the right result for the test input. We are not able to get to the real result. We are using weight as a potential option. We're adding cost before we check we can walk somewhere. We are checking for all the blizzards. We fixed the N and M mix-up. The -1 + 1 is working. Hmm, fascinating. Fascinating. See, I'm confused because I'm not really sure how to fix this now that we did get to the right result for the test input. I mean, there's probably something wrong here, but I couldn't tell you what it is. Hmm. Well, let's do some printing. We're getting stuck after 18. Oh, no, we're solving it after 18. So what happens here? Just none. What the heck? Oh, we have to wait before we start moving. Mm. if new p not equal to start, because we can go to start position. Okay, this is looking. This should, in theory, get us to the goal. Only we should actually keep track of the start, the visited stuff, only in a bit of a different manner, because there's too many different ways in which we are able to get to positions. So we got position comma 0. Yes. This should speed things up considerably. It's still gonna take a while, I'm pretty sure, but not forever. Um, I do wonder if now that we fixed this, we might be able to actually set this here to 0 and check if we can still put in the test example. No, we cannot. Wait, why do we get stuck now? Uh, Shoot. Yeah, I'm not too happy with this endless loop with the starting position. Okay, how about this? We go back to what worked. 18. We remove the print. And we give this thing a whole bunch of starting arrangements. We can wait from 0 10. Still 18, of course. A string equals empty string. Let's see, let's see, let's see. Actually, I want to try this in a bit of a different way. Res equals none, while res is none. C equals 0. C plus equals. Okay, I think now we're exploring 0 starting wait, then we're waiting 1, exploring all the options, and so on and so forth. We should probably print C, make sure stuff's happening here. I would love to remember the positions that might be. Yeah, if you wait one, this is already exploding into infinity. Um, so let's do actually put back all the visiting stuff, whatever we have visited before. We might have to go back to what we have visited, but we will never have to go back to um, what we have visited with the same cost. And in fact, cost is going up anyway, so this doesn't really matter a lot. This optimization isn't going to help a ton, so keep that in mind. Let's see though. I'm carefully optimistic that this is going to find something. I mean, there is a chance that it's just going to go back and forth forever. Hmm. I should probably print the current cost, huh? I feel like we should define a sane cutoff point at like 80. If cost equals 80 return. So now we're gonna go to 80. Yeah. I mean, how much waiting are we gonna do? The cycle is up to n, which is 122. Dude, we're never gonna be there until we get to 80. Dude, this is tricky. I don't know. Maybe we can optimize more our method, finding out if it's a hit, but I'm not sure. I'm not sure. So it's 122 times plus 30, so like 150. Um, I don't think it's gonna be a lot more than. Oops, yeah, this is what's causing the control C to not work anymore. So let's say 180 is our cutoff point. I'm not sure. How can we do better here? We are doing a lot of computing here. Maybe we can cache some of these results. Uh, Not sure if that's really gonna help things. Okay, waiting more than 5 turns in the starting position is gonna be unlikely. So let's just increase this to like 300. Start again. And then I think we're just gonna let it run for a while. We can pre-compute all of these positions. Um, I mean, n times m is like 30 times 120. Um, Weird, different positions. So we can really go through every single. You know what? Let's do that. Yeah, 100%. Okay. Um, for I in range of 1 up to n plus 1, and for j in range of n plus 1, noblesse dict equals this. And then for t in range of n times n. Noblesse dict of ij is equal to no, to noblesse of I j t. Amazing. And now we can do noblesse fast of x, y, t and return no list dict of x, y, and t modulo n times n. Amazing. I think this is going to work. This is going to increase speed a lot, I hope. So let's not, like, we can go to 1,000. T reference before assignment. Ah, yes. Well, let's call it IJK. How about some K? Now, I am a little bit worried about how much memory this process is going to take up now. And it is going to run for a while. That's for certain. So we could improve it and say we only run through all the blizzards by time and not. Ugh. Yeah, we should do that. I mean, how long is it gonna take to set this to true? Not very long, so we should really go through for position and movement in Blizzard. X, Y, MX, no, Y equals position, MX, MY equals movement for A in range and times N. So we should probably say um, x minus equals 1, y minus equals 1, x plus equals mx, and y plus equals my. Then x equals m. This is false. It should actually be m. And here we say no blitz dict of x, y, and k equals false, except we have to add 1 to the mix. So now I think we should be good. Um, yes, we did it. Oh my goodness. Wow, so much pre-computing to be done here. As the expedition reaches the far side of the valley, one of the elves looks dismayed. He forgot his snacks at the entrance of the valley. You're so good at dodging blizzards. Request that you go back for snacks from the same initial conditions. How quickly can you make it from the start to the goal, then back to the start? And then back to the goal? Are you kidding me? Wow. So this stuff is gonna go out of the window. Oh boy. So what we have to do is flip the start and the end, figure out how much of a problem it is that we're. So this has to go up here now. I think this is still a good cutoff. So we got uh big C equals 0. C plus equals the result. Now we do this 2 more times with this at the very end, except every time we have to do this. And we have to flip the start and the finish. So this is going to be 0, 1. This is going to be this. So now we print C0 plus C2. And I want to see if this works for 54. Would be the output for the testing stuff. Let's see if this works. Nope. What are you talking about? C plus equals res. Oh, that kind of makes sense. Yeah, that's a little high, to be honest with you. Maybe we should just do this. Yeah, we just do this. I think we got this in the bag. Um, I mean, it's gonna take a while, but yeah, we got it. Okay, so this, since this has been the first day for a long time where I actually know what I'm doing, and I got the right approach at the very end finally, I do want to explain what's happening here. But first of all of these print C's have to go. Okay. So now we should be able to run this. It's going to take ages to pre-compute all the stuff we need to pre-compute. And then it's going to get the first result out pretty quick. And then the other two out pretty quick as well. So what's happening here? Well, first of all, I just tried to do a regular BFS. And then I pretty quickly figured out that this method here, the no blitz, while it doesn't take super long for one cell, if you execute it in like a huge BFS time complexity cubicle arrangement, because you have so many different opportunities to go through, really adds up fast. So you really need something that runs in constant time here. How do you do that? In order to get this to constant time, you can pre-compute all of the potential positions and if they're a go or not. And how do you pre-compute this? Well, first I try to do it the manual way by calling no blitz. Now with the current way, we're actually not using this method anymore at all. So we're just going through all of the different blizzards. We're going through all the possible time points, which are, again, this is the little modulo trick. If you got modulo n sometimes, modulo m sometimes, then it's all going to repeat if you multiply them together. Um, there might have been a way to do this faster. Actually, no, I don't think there would have been because n and m are of different dimensions. So, and we figured this out by looking at the input. This was very helpful to not mess up. So there's also a little trick where we remove one and we add one to the values in this order so that we only have to do it one time and we can do the modulo in an easy way without constantly adding and subtracting stuff. This is just going through and making sure every time a blizzard visits a field at a point in time, we're going to set that value to false in the does it have no blizzard dictionary. Now, BFS is completely straightforward. We just copied it from the previous days. The important thing here is that these conditions are not true for the goal. So you have to do the goal check before you check if you're out of bounds, because you can always go to the goal um, even if it's outside of the bounds. And the important part is that we don't want to go back to the goal to the starting point outside of the walls ever. So I made this little hack here where we just have different waiting times. So we're starting at a waiting time of 0. If that doesn't give us a result, we wait for 1. And then there's like a little cutoff here. This is just an optimization that I probably don't even have to do anymore. Where I was like, yeah, maybe we should um, kind of after a certain point in time say this is no good. Um, yeah, so we don't need that anymore. Because I wasn't sure if my optimization was working or not. We were trying out different things of going back into the walls and going back to the starting position. The easiest thing is just to bake in different starting cost values here. So at some point, you're just going to run out of options. If you can never go back, you're just gonna run into a wall and you cannot continue if you didn't wait long enough at the start. So this way, we're just making sure that we're waiting the sufficient amount of time before going into the maze so that we're ending up with a constellation that's actually gonna work. Um, yeah, period. I think this is pretty much it. There's no secret sauce here. It's all just optimizing what you're pre-computing, figuring out that you have to pre-compute, how you have to pre-compute, doing smart things, and um, yeah, no, I'm very happy with this. I'm gonna guess we get like a 400 or something. Yeah, 7 and 600. It's fine. I'm kind of happy with this. It was a fun little puzzle. we went through quite a lot of iterations of trying to solve this because I couldn't figure out how and what to pre-compute. Um, and we got a lot of people who don't speak English in the chat, which is fun. Okay, I I'm gonna go to bed. It's 1 a.m. Thanks for sticking around, and we'll do the final newly released puzzle tomorrow at the same time. See you then.